In talking about inertia here and not being flung out and so on, I'm trying to avoid hard an expression called centrifugal force. It does not exist. There is no such thing as centrifugal force, and I admit that in everyday language we use it all the time. However, what we really do talk about is inertia. In a curve, the reason your body seems to go to the outside is because it already was on the outside and it wants to stay there because of its inertia, and that's what we refer to with that term that actually does not exist. And I'll be sticking with inertia if you want to go to the outside, and centripetal acceleration because, and force, centripetal force as well, because that is actually changing the direction here. Okay, I want to talk about, in this curve here, what actually supplies the centripetal acceleration. Well, if it was just inertia, if this was an icy road, then the car, of course, wouldn't get into the curve, it would just move out there. So it has to be something. Well, there's this little pin here that fits nicely into the slot, and then no matter what I do, it wants to stay in the slot here, which is why these are called slot car race tracks. So this pin here stays in the slot, and it's the support force of the slot that is pushing it towards the inside. There is also static friction here of the tires that is pushing it to the inside, and the same thing is for your car as well. And I actually should point out from earlier, I kind of forgot that it's really the tires that are pushing back that actually propel it forward. I cannot show this if the whole thing is moving, so what I'm going to do is I hold this up and we should see the tire spinning if I have it on the right track, or if I have it pushed down far enough. There we go. So here we actually see the tire spinning. So really, in order to propel itself forward, it's the tires pushing back on the road, and then we have Newton's third law that is pushing the tire forward from the track. So the track is being pushed back, and in turn, Newton's third law, action reaction principle, the track is pushing the tire forward. The reason I remember that is because that also requires static friction. Of course, kinetic friction tries to slow it down in the opposite direction, and as it goes into the curve here, there's also static friction, but now perpendicular to the tires pushing inwards. So in the slot car here, it's the support force of the slot pushing the pin inwards, as well as the static friction pushing it inwards. And if I try to pull this car off the track here, I actually see that I pull the track up, and that's simply because there's a little magnet at the bottom here that also supplies a certain amount of force to supply that centripetal force. If that magnet wasn't there, then the car actually would do this. There are actually slot car races that do that more realistically, but this one here is, as you can see, more for little kids, so they want to keep it stable. So there's a third force that supplies the centripetal force, and that's the magnetic attraction. In a banked curve, like this one here in the banked curve, well, here we have the support force at an angle with the vertical, and therefore there is also an inward component of that that supplies the, oops, this broke off here, that supplies also part of the centripetal force. Best seen actually here when I put it here, where I have my support force being perpendicular to the track, and so there's a component to the inside that also keeps it going this way here, so that it's not going to fall on the track. Of course, here also gravity tries to pull it down, and that's where that magnet comes in pretty handy, as it sticks, as the car sticks to the metallic, or the metallic track that contains some iron. How does the car actually run? Well, on this racetrack here, you see the metal here, and that's of course connected to an outlet and a transformer to get the voltage down and convert it to DC. And then we have these little brushes here that are picking up the electrical current, sending it to a DC motor in the back here that then is connected to a gear that is applying a torque on the wheels. Do I do this the right direction? No, actually no, it would turn backwards, move backwards, so the wheels are turning this way. So a torque here, and then with the radius of the wheels, a certain force is applied to the tracks that then in turn again Newton's third law propels the car forward. There's a control that comes with it to control the speed. So by pushing down here, let's see, oh, maybe I'm on the wrong, no, I'm on the right track, I believe. Yeah, there we go. I just have to push the brushes down far enough. So here I release the control a little bit, or I push it really down and it gets really fast. So there's a resistor in here that changes the electrical current that goes through here. So the further I push it down, the more electrical current is coming through, the more powering the motor, the putting on more torque, putting on more force, and that force then multiplied with the distance puts a certain amount of work into the car. Then that work measured in joules would then become additional kinetic energy, and kinetic energy of course is related to the velocity squared, so increasing therefore the speed of the car. I had mentioned earlier that the car actually needs to accelerate here, and it starts it over there all this way around this loop here in order to actually make it up and go through. So it needs to accelerate in order to get to a certain top speed, because on the way up, of course, gravity is slowing it down, trying to slow it down. Of course, I can try to push the control harder and make and accelerate it faster, but that's what I'm doing all the way through here to get it to a top speed. So gravity is trying to pull it down, which is another way of saying that it comes on here with a certain kinetic energy on the way up. It's gaining potential energy, and where does it come from? Well, from the kinetic energy. That's the conservation of energy. You can only have so much combined, and therefore as it's gaining potential energy, it has to lose kinetic energy, so the velocity goes down. So then it goes up here, and then actually what keeps it on the track? Well, of course you can see that the magnet somewhat keeps it on the track, but the magnet isn't strong enough to keep it up there. So it has to have a certain amount of speed to go through here, and at any point here it's pretty much the gravity this way actually, and the component this way here, and the support force from the track that is supplying that centripetal force here, which results in a centripetal acceleration as the car goes around the loop. So again, it's the support force of the track, and especially the gravity that supplies this centripetal force and centripetal acceleration as it goes around here. Okay, so what happens when it's on the very top? Well, here of course gravity tries to pull it down, and gravity is the sole provider of the centripetal force if it's at the right speed. What if it's slower? What if it's zero? Well, if there is a speed of 0, it's just going to fall out. You know, in fact, it would have done so already before, because over here it would have been too slow. What if it is not 0 but still too slow? Well, at that point it's just going to take off here. Gravity is too strong, and it's applying more than necessary for the centripetal force, and therefore it's just going to take off in the trajectory and crashes. Okay, what if it's just right, so that the centripetal force, which is mass times velocity squared divided by radius, equals gravity? Well, at that point, as the car goes through here with that just right speed, at that point here, it just barely wants to get off the track and barely stay on the track, so gravity supplies the entire centripetal force and keeping it therefore in this loop here. At that point, what is actually the driver feeling? Well, the driver is feeling kind of like in free fall. It's not quite falling yet, but barely. It wants to start free falling, and the driver and the car are almost in free fall, and therefore the driver would be actually feeling kind of weightless.